Hello everyone, this is Sandeep. You are watching Samyan's Academy, and in this session we are going to discuss about electric current and its effect. Let us start now. So here we have some electric components: electric cells, electric bulb, switch in and off position, and battery is there, wire. Then what is the symbol of the electric cell? The symbol of the electric cell you have to represent it with the two terminals, right? So this is the battery. Positive terminal you have to represent it with the longer line, and the negative terminal you have to represent with the smaller line. Okay, this is the symbol of the cell or battery. So battery is having the electric, so not battery. So cell is having the two terminal, one is positive terminal and the other one is negative terminal. So positive terminal you have to represent with the bigger line, and the negative terminal you have to represent with the smaller line. Okay, and electric bulb, so this electric bulb you have to represent like this. So this is the symbol of the electric bulb, so you have to represent like this. Okay, so this is the symbol of electric bulb. Now you see, when you switch on that, what will happen? The light get on. When you switch off that, light get off, right? Then how do you represent the key, switch key? The switch key, so we have to represent like this. Then switch key we have to represent like this. Now this is it, this is not in contact, and this pin is not in contact with the other end. So this means the switch is open here. Okay, here the switch is open. Here the switch is open. Okay, so when this pin is contact with the other terminal of the wire, so in that case the switch is closed now. So in this case the switch is closed. So okay, open switch you have to represent this symbol with this symbol, and closed switch you have to represent with this symbol. Okay, and now battery. So battery is a combination of three or more cells or two or more cells. When you combine these cells in series, you will get the battery. Battery is a combination of two or more cells, which we called as battery. So this is the battery, and the battery is a combination of two or more cells. Each cell is having the positive terminal and a negative terminal. Then this negative terminal of the one of the battery, when you connect with the positive terminal of the other battery, and similarly you connect with the negative terminal of the other battery with positive terminal of the other battery. So if you go on like this, the combination of all cells gives the battery. Okay, cell will be represented with the only big line with the positive terminal, small with the negative terminal. When you connect like these cells two or more, so it will give the battery. Is it clear? So these are the symbols of cell, bulb, and switch off, key which is in the off position, key which is in on position, and this is the battery. So this is a combination of all cells. And also we have your wire. How do you represent the wire? So wire we can represent with the line. Okay, so this is the wire, so this we can represent with this line. Okay, so now move on to the next one. Yeah, so electric cell, already you know that electric cell whatever we used in the watch. Okay, and where we can use these electric cells, can you tell? In remote batteries or remote, and where we can use in wall clocks, and so tell some other examples where we can use. Yeah, either in TV remotes, AC remotes, or in all remote toys, right? We are using this battery. So electric cell has a positive terminal and negative terminal. The symbol of an electric cell has a longer line and a shorter line. The longer line is the positive terminal and the shorter line is the negative terminal. So as earlier we discussed this. So the longer line of the battery indicates the positive terminal. Okay, the longer line indicates the positive terminal. The shorter line indicates the negative terminal. Okay. Now battery means it is a combination of two or more cells. Just now we have discussed, when you combine all the cells like this, so it will represent the battery. Okay, when you combine all these cells like this, so when you combine all this cell like this, so it represents the battery. How we are connecting? Like in torchlight we are using the two or more batteries. Then how you are keeping the batteries in the torchlight, cells in the torchlight, like this. Okay, this is the positive terminal, this is the positive terminal of the battery, and this end is the negative terminal. Again you put positive terminal to negative terminal, positive terminal to negative terminal. When you arrange like this, so it will give the combination of 2 or 3 or more cells gives the battery. Okay, then how do you connect this battery? Positive terminal of the one of the battery to negative terminal of the battery. So next another battery, positive terminal, negative terminal, positive terminal, negative terminal. If you connect like this, so combination of 2 or more cells we called as battery. So in a battery, a positive terminal of the one of the cell is connected to the negative terminal of the another cell. Now you see, this is the positive terminal of the one of the battery which is connected to negative terminal of the other battery. Okay, so devices like torch, transistors, toys, TV remote controls, we use these batteries. Okay, what is cell? Cell is having how many terminals? Two terminals. One is the positive terminal and other one is a negative terminal. Positive terminal we represented with the longer line and negative terminal we represented with the shorter line. Okay, that is the cell, not battery. Electric cell. Electric cell we represent with the two terminals. Positive terminal represent the longer line and negative negative line represents the shorter line. Okay, negative terminal represent the shorter line. So what is the battery? When you combine the two or more cells in this way, so this will give the battery. A battery is a combination of two or more cells in a battery. So the positive terminal of the one cell, and this is a positive terminal of the one cell. Just a minute. The positive terminal of the one cell we are connecting like this. Now you see, this is the positive terminal of the one cell which we can connected with the negative terminal of the other one. Okay, when negative terminal of the one cell which we connected with the positive terminal of the positive terminal of other cell. So when you connect like this, it will give the battery, right? So where we can use the like these devices, so this battery we can use on the torch, transistors, toys, TV remote and remote controls used as a batteries. Now you see, move on to the next one, heating effect of electric current. Now you see, when you use any devices for longer time, so it will get heated up, right? So when you use anything, so if you use any components, electric components for using longer time, it will get heated up. The heating effect of electric current we are going to study now here. When electric current flows through a wire, the wire gets heated. This is called the heating effect of electric current. So to perform this activity, so you have to set like this arrangement. Make an electric circuit as shown in the figure. Take a 10 centimeter long nichrome wire and tie it between the two nails. Okay, so what we have doing here, so we are connecting one circuit. Here we are taking the two nails. Here we are taking the two nails. So this is a nail. Yeah, here we are taking the two nails, right? Here also we have one more nail is there, and these two nails. And what is the length of this two nail? What is the length of that? So suppose you assume this is a 5 centimeter length, and you connect in these two nails in the electric circuit by using one battery, smaller battery. You connect like this. So it is having small key. When you switch on the key, what will happen? The electricity is passed through these two terminals, and these two nails you connect with the one nichrome wire. Okay, what is the length of the nichrome wire we are taking here? 10 centimeter long nichrome wire we are taking, right? And tie it between the two nails. So we are tying between the two nails, this. Okay, then now you switch on the current. For switching on this current, so what you have to do, you have to you have to join these two terminals. Now the current flows from this battery. Then what will happen? Then what will happen after a few seconds? When you touch the wire, so before touching the wire, just you switch off this current, and after few minutes you touch this wire. Then you observe that the wire get heated, right? So this shows that when electric current flows through a wire, it gets heated. Okay, what we are doing here, so you are taking the two iron nails, these two iron nails connected with the nichrome wire. When switch is on, then what will happen? The current flows through this nichrome wire. After few minutes, what will happen? This nichrome wire gets heated up. Okay, from this experiment we confirm that when electric current flows through any wire, the wire gets heated, and this is called as heating effect of electric current. Is it clear? Okay, now move on to the next one. Uses of heating effect of electric current. So by using this heating effect, and this heat we are using in the several devices, in iron boxes and the kettle, electric kettle box, electric room heaters, electric heaters, like toasters. We are using and electric geysers also. And where we are using this heating effect of electric current, in so several devices we are using. Where we are using? In iron boxes, in electric room heater, electric heater, and electric kettle, and geyser, like toasters. We are using this heating effect, right? The heating effect of electric current is used in electrical appliances like electric heater, electric iron, electric room heater, immersion heater, electric kettle, and hair dryer. All these appliances have a coil of wire called an element. Now you see here, we can see the coil of element. Now all these is having, all these electric heaters are everyone, this one and electric iron, inside these appliances we have some coil, electric coil, right? All these appliances have a coil of wire called an element. When electric current flows through this element, it becomes hot and gives out of heat, right? The amount of heat produced in a wire depends upon its material, length, and thickness, right? When you take more thickness of the wire, so it will give the more heat, it generates more heat. When you take more length of the wire, it will give it also gives a more heat, it produces more heat. And the thickness, if thickness is more, the generation of heat also more, right? So it depends on the wire. So wire, the amount of heat produced depends on the material, length, and thickness of the wire. Is it clear? Okay, so this is the uses of heating effect of electric current. Now electric fuse is there. So this electric fuse is a safety device which is used in the electrical circuits, which protect the electrical circuits and appliances also. How it will protect? Suppose now you see, this is the fuse wire, it is having one thin wire, so this connected the two terminals of the fuse. Then what will happen? When excess current flows through it, what will happen? The excess current first flows through this fuse first. Okay, before coming the electricity to our home, the electricity first moves to this electric fuse. Okay, the electricity first flows from the electric fuse. At that time, what will happen? When it is excess current is moves from this electric fuse, the wire which is connected these two terminal in the fuse, which get heated up, and because of that heat it will get broke, means it will get broken, means because of that heat it will get melt and it will get broken, means it stops the electric current here only. It won't allow the excess electricity into our home. If excess electricity is passed into our home, then what will happen? Yeah, it may damage all appliances which are connected in the electric circuit. Suppose excess amount of current flows means that monitors get damaged, TV get damaged, and everything whatever we connected in the electric circuit, all will get damaged. Okay, so it will prevent, so it do not allow the excess electricity through it. Okay, when excess electricity is passed through it, what will happen? First it will get fuse means it will get melt and it will broke. Okay, because of that electricity is not again it is further passing into our home, right? So in this way the electric fuses works. Electric fuse is used in all electrical circuits in the buildings. Electric fuse has a wire which melts quickly and break when large electric current flows through it. Okay, when the large electric current flows through it, what will happen? It will get melt and break. So because of that, the large excess current will not pass to into our electric circuit, and also we save the all appliances from the fire also, from damage also, from electrical damage, shock also, right? Then move on to the next one, magnetic effect of electric current. Okay, when electric current flows through any wire, it behaves like a magnet. Okay, to perform this activity, you take one iron nail, one smaller activity. Okay, you take one iron nail. To this iron nail, just you wrap the copper wire in many circular turns. You take the one copper insulated wire, you take the copper wire, you take first iron nail, like this iron nail you take. Okay, to this what you have to do? You have to wind the wire in many circular turns. Okay, two terminals of the wire you connected with the battery. After some time, what will happen? This iron nail behaves like a magnet. Okay, behaves like a magnet. So what happens here? When electricity is passed through any conducting wire, it gives a magnetic field. It generates a magnetic field around it. Due to that magnetic field, the iron nail get magnetized. Okay, and because by using this iron nail, we can this iron nail now it is acts as a magnet. Okay, you take some small pins, so it will get attract like this. Okay, now you see here we have an activity to perform this magnetic effect of electric current. When electric current flows through a wire, it behaves like a magnet. So this is called magnetic effect of electric current. So here we have the activity: take the cardboard tray from a matchbox, wind an electric wire a few times around the cardboard tray. What we are doing here? So we have taken one cardboard. Okay, we have taken cardboard. To this we are winding the electric wire like this. Many circular turns we are winding, and these two terminals of the wire we connected with the positive terminal and negative terminal. We key is there, and in this circuit we connected one small bulb also. Okay. Now place a small compass needle inside it. So here we have the compass needle inside it. When the switch is on, the compass needle gets deflect. Okay. So when that compass needle get deflects, whenever there is a magnetic field, at that time only the compass needle get deflect. Okay. When the switch is on, the compass needle deflects. When the switch is off, the compass needle come back to its original position. Okay. When switch is on, what will happen? The deflection takes place. When switch is off, what will happen? It come back to the rest. So here we have one activity. I will show you that activity. So who has done this experiment? Eierster has done this experiment. Okay, now you see this is a compass. Always it will show the north, south. Okay, north pole towards this red color indicates the north pole, and the other side indicates the south pole. Okay, so when you take the any magnet to this compass, what will happen? It will get deflect. Now you see that indicates the north pole and south pole. When you take the other magnet nearer to this compass, it will get deflect. Means if there is any magnetic field around it, the compass needle get deflect. Okay, so before going to this, so what we are doing here, we are taking the one magnet nearer to it. Now we are seeing the deflection in the compass needle. Now what we are doing, this is a battery is having the positive terminal and negative terminal. Okay, when you connect the wire to this, what will happen? The current will flow from this wire from positive terminal to negative terminal. Now we can see the deflection. Okay, before this is towards north terminal, now it is moved towards to the west direction. Okay, now when you remove the current, when there is no current in the conducting wire, it comes at rest. Okay, now what we are doing, we are reversing the direction of the current. Now we can observe the deflection in reverse direction. Okay, previously it was deflected towards west direction, now it was deflected towards east direction. Means when you reverse the direction of the current, and the magnetic needle deflect in reverse direction. Okay, so from this activity we confirm that whenever there is a magnetic region, magnetic field, at that time only the compass needle get deflects. Okay, are you getting my point? Yes. Whenever the electricity is passed through this wire, the wire creates some magnetic field. Because of that magnetic field, here compass gets deflect. Is it clear, everyone? Because of that magnetic field, the compass needle gets deflect. Now, when the switch is on, the compass needle gets deflect. When the switch is off, the compass needle comes at rest. Okay, now you see, when the switch is off, the compass needle comes back to its original position. And this shows that when electric current flows through a wire, it behaves like a magnet. Okay, whenever there is electric current in the wire, there is a magnetic field around it. It will produce, right? So this is about magnetic effect of electric current. Now, just now I have told you, take one iron nail, just you wind the some copper wire to it. Then what will happen? So it will behave as magnet. Yes, now to perform this activity, we have taken one iron nail. Now you see, Now you see, to perform this activity, we are taking one iron nail. So to this, we are winding the copper wire. To this, we are winding the copper wire. Now you see, we are taking one iron nail, and to this, we have taken one cell also. So like this, you wind the copper wire around the iron nail. Okay, the two ends you connected with the cell, and now it will acts as a magnet. So it will attract the small iron nails. Now you see it attracting the small iron nails. Okay. Now this phenomena we called as electromagnet. Okay. Now you see, when electric current is passed through a coil of insulated wire wound around a piece of iron, it becomes a magnet. Such magnet is called as electromagnet. Okay. Wind a piece of insulated wire around an iron nail in the form of a coil like this and connect the free ends of the wire to an electric cell through a switch. Place some pins nearer to the nail. When electric current is passed, the iron nail becomes a magnet. So and attracts the pins also. When electric current is switched off, the nail loses its magnetism. Okay. Whenever it will act as magnet, whenever there is a current passed through it, at that time only it behaves as a magnet. When you switch off the current, what will happen? It will get demagnetized. Means whenever the current is passed through the iron nail, then only the magnetic field it get produced. Because of that magnetic field, it behaves as a magnet. When you switch off the battery, then what will happen in that case? There is no magnetic field, means it will get demagnetized. Okay. When electric current is switched off, the nail loses its magnetism. Right. So this is about electromagnet. Move on to the next one, electric bell. Electric bell. The electric bell has a coil of wire wound around a piece of iron which acts like a electromagnet. Now you see, we have taken one wire, so which is wound to the piece of the iron, so which acts like as a electromagnet. This is a contact screw near the iron strip. Okay, and we have the contact screw is there, so which is a nearer to the iron strip. When the iron strip is contact with the screw, current flows through the coil and becomes an electromagnet. Now you see, here these two are contact with each other. When current flows through it, it will get contact to each other. Okay, whenever it will comes to contact, the current will flows through this circuit. Okay, the current will flow from positive terminal of the battery to negative terminal, and then it will come to here, then it will reaches to the negative terminal. So what happens when current flows through this system? It will get magnetized. It will get magnetized. Because of that, what will happen here? Because of that, what will happen? Here some gap is there. To this striker and to this magnet, some gap is there. To this striker and to this magnet, this is the striker which is placed nearer to the bell, and here the magnet is there, iron nail is there. So here some gap is there. Whenever the current flows through it, what will happen? It will get magnetized. Because of that magnetism, what will happen? It will get attract towards the this iron nail or magnet. Okay, then what will happen? Whenever it moves here, then what will happen? The contact will get detached. Are you getting my point? Whenever the current flows through it, it will get magnetized. Then it will attract this striker towards in its direction. Because of that, what will happen? Here the contact is comes to break. Now the contact will break from the striker to contact. There is some gap will happen here. At that time, the current stops. The flow of current stop. When there is no current, when there is no magnetism, then it will get demagnified, and the it will get detached from this magnet, and again the contact will come to play here. Now whenever it contact again the current flows, then what will happen? Again it will get magnetized, again the strip come nearer to this magnet, again the again what will happen? Here some gap will form. Because of that, the current flow stop. Again the flows of current stop, then what will happen? This will get demagnetized again. So it will go on like this. This is a continuous process. Because of that, so one time it will get magnetized, other time it will get demagnetized. Whenever it will get magnetized, it attracts the strike, and we can hear the bell sound. Whenever it get demagnetized and it detach the striker, here we cannot hear the bell sound. Again the next second what will happen, again the current flows, again it will get magnetized, again it will attract the striker. Whenever it attract the striker, we can hear the sound. Like that it will go continuous like this. Like this it will get continue. This is the striker and this is the bell. You assume it will get detached and it will get attached. Like this it go on frequently. Within the few seconds it will come nearer to it. Within the few seconds it go back again. So this process will continue, and then we hear the sound of the bell, right? Like that ringing sound we can hear, right? Now you see, there is a contact screw near the iron strip. When the iron strip is in contact with the screw, current flows through the coil and becomes an electromagnet. Okay. Whenever there is a contact, what will happen? The current flows through this wire and it will get magnetized. And what will happen? It pulls the iron strip, and the hammer the end of the strip strikes the gong of the bell and produces sound. When electromagnets pull the iron strip, then what will happen? It also breaks the electric circuit, and the iron strip comes back to the original position, and the process repeats and the bell rings like this. Are you getting my point? Then how the electric bell is works? Okay, now, yeah, this is your lesson, electric current and its effect. And if you like this video, please subscribe, share and comment. Thank you for watching. Bye.